Hello, Namaskara. Welcome to Tech Girl Kannada YouTube channel. Module 5 DBMS. What is meant by this concurrent execution of a database transaction in a multi-user system? What is this concurrent execution of transaction? Means that multiple transactions are allowed to execute simultaneously or interleaved on the same data items in the multi-user system. The operations like read or write of different transactions are interleaved in a time, sharing CPU or IO resources, while the DBMS ensures that final result is correct and consistent. Why this concurrency control and recovery is needed for DBMS? Explain the types of problems that may occur when two simple transactions run concurrently. They are needed to ensure correctness, consistency, reliability, and isolation of data. When multiple transactions execute concurrently and in the presence of failures, problems that may occur when two transactions run concurrently. Lost update problem. One transaction's update is overwritten by another transaction, so the first update is lost. Dirty read, uncommitted dependency. The transaction reads data written by another transaction that is not yet committed. If the writer aborts, the reader has read invalid data. Non-repeatable read. A transaction reads the same data item twice and gets different values because another transaction updated and committed the item in between. Phantom read. A transaction is re-executes a query, select with where clause, and gets a different set of rows because another transaction inserted or deleted rows that at that specific that satisfy the condition. Dirty read, non-repeatable read, and lost update problem. When does deadlock and starvation problem occur? Explain how these problems can be resolved. Deadlock. What is deadlock? Occurs when two or more transactions are waiting for each other to release locks on data items and none can proceed further. Circular wait condition situation. Conditions for deadlock are mutual exclusion. A resource is held in non shareable mode. Hold and wait. A transaction hold one resource and wait for another. No preemption. Resources cannot be forcibly taken out, they are released only voluntarily. Circular wait. There exists a circular chain of transaction each waiting for a resource held by the next one. How to resolve this deadlock? Prevention. Ensure at least one of the above conditions never holds. Avoidance. Grant logs only if the state remains safe. Wait, die, owned, wait. Detection and recovery. Detect deadlock, wait for graph, and abort or roll back one or more transactions to break the cycle. What is starvation? Occurs when a transaction waits indefinitely because other transactions keep getting the required resources repeatedly. How to resolve starvation? Aging. Increase the priority of waiting in transactions over time. Fair scheduling. Use FIFO priority queues to ensure fairness. Timers. Abort and restart if waiting exceeds a threshold. Fair scheduling and timeouts. Then explain how shadow paging helps to recover from transaction failure. What is this shadow paging? Shadow paging is a recovery technique that keeps a shadow copy, another set of page table and data pages of the database. all updates are first made to the shadow copy. The original database is not modified until the transaction is committed. How it works? Before a transaction starts, a system keeps current page table pointing to the committed master pages. Then shadow page table. A copy of the current page table is kept. When an update is issued, the required page is copied to a new shadow page if not already copied, and then the update is applied there. The shadow page table entry is changed to point to this in the page. This way, all updates of the transactions are recorded in the shadow pages only. If the transaction commits, the shadow page table becomes the current page table. Shadow pages are the new committed pages. If the transaction aborts or fails, discard the shadow page table and all shadow pages. Continue using the old master page table and pages that is given in this diagram. Master page table which is committed P1, P2 to Pn. Shadow page table working copy P-1, P-2, P-n. P1 is the master page, P-1 is the shadow page. Advantages of this shadow paging: simple and fast recovery, no undo is required, ensures atomicity. Either all updates becomes visible by commit or none, that is abort. Briefly discuss the two-phase locking techniques used were concurrency control. Two-phase locking system is a lock-based protocol that ensures serializable schedules. It has two phases: growing phase, lock acquisition phase; shrinking phase, lock releasing phase. In between, there will be a lock point. It's a lock based protocol that ensures conflict serializable schedules. Transaction can acquire locks S lock, X lock, but cannot release any lock. That is lock acquisition phase, that is growing phase. Shrink In the shrinking phase, we have transaction can release locks but cannot acquire any new lock. Lock types used are shared lock, that is S lock for read operation, exclusive lock, X lock for write operation. Variants of two-phase locking systems are: basic two-phase locking system follows the two phases strictly, guarantees conflict serializability but may cause deadlocks. Conservative static two-phase locking. Transaction obtains all required locks before it starts, deadlock free, but low concurrency. Strict two-phase locking holds all X locks till commit or abort, prevents cascading rollbacks. Rigorous two-phase locking holds both S locks and X locks till commit, produces strict schedules. For example, for transaction 1 T1, we have time and their operations. T1 to T8, log S of A, read A, log X of B, write B, then unlock A, unlock B, where it is the logs are acquiring locks that is growing phase, where they are releasing locks, that is shrinking phase. Then we have defined transactions. Discuss the asset or desirable properties of transaction. Explain with an example. Transaction. A transaction is a sequence of one or more database operations treated as a single logical unit of work. It either completes successfully or has no effect. Sequence of one or more database operations as a single logical unit of work. Then the asset properties or the desirable properties of the transaction. A for atomicity. All operations in the transaction are treated as a single unit. Either all are executed or none, all or nothing. C for consistency. A transaction takes the database from one consistent state to another consistent state. It preserves all integrity constraints. Transaction takes the database from one consistent state to another consistent state. Then I for isolation. Concurrent transactions do not interfere with each other. The intermediate results of the transactions are not visible to others. Durability. Once a transaction is committed, its effects are permanent and survive failures of a system. For example, we have consider a book transfer of bank transfer 500 rupees from account A to account B. Transaction T is read A equals to A minus 500, write A. Then read B equals to B plus 500, write B. Then property and how it is satisfied in the example. Atomicity. Either both A is debited and B is credited, or neither happens. Consistency. Total balance A plus B remains the same even before the transaction as well as after the transaction. Database constraints. Example, balance greater than or equals to 0 are preserved. Isolation. If another transaction reads A or B while T is executing, it will see either the old values or the new values, not the intermediate ones. Durability. After T commits, even if the system crashes, the transfer of rupees 500 will remain permanent. Thank you for watching. Do like, share, and subscribe to my channel.